Okay, so here we are with level 1 formula writing. It's basically dealing with ionic and covalent bonding. There's a few basics that you do need to know before kind of going in a little bit more deeper in here, because as you read these notes, you're going to see they're going to talk about metals and non-metals, and you do need to know the structure of the periodic table just a little bit. So if we take a look at this, okay, you're going to see that we have this staircase that starts on the left hand side of boron, and it's down 1 over 1 all the way down. If you're over here, we're talking about the nonmetals, and really anything over to the left we're going to call metals, with the exception of hydrogen. And the other very important piece of information before we get into any of our formula writing is for ionic compounds. Remember, ions are things that have charge. We need to know where the charges are on the periodic table. And it's pretty simple. Starting on the left-hand side, you start with 1 plus, 2 plus, and then we're skipping these 10, and this is going to be positive 3. And then from the right-hand side, that first column is neutral, no charge, and that's -1, -2, and -3. Okay, now you might say, well, what about this middle column? Okay, it actually can be plus or minus 4, but a lot of these elements share their electrons. They don't transfer their electrons, and therefore a lot of times they don't make ions. And remember, ions are charged atoms, so we pretty much don't have to really pay too much attention to column 14 at this moment in time of your chemistry instruction. So we're going to use this and this to kind of go through level 1, which is the foundations of formula writing. So let's get back to where our notes are that we got from Google Classroom. And let's start out with covalent bonding, okay, as far as formula writing is concerned, okay? And if we just kind of read together, in covalent bonding, there can be a number of combinations of the two nonmetals, okay? Remember, there's no loss or gain of electrons, so nothing is charged here, okay? And because they're not charged, there's all these combinations that the nonmetals can combine in, and therefore we do need to use prefixes, okay? Now there's 5 prefixes that you need to know. You might want to write this down. We'll put it off here to the side, but the prefix for 1 is going to be mono. The prefix for 2 is going to be di. The prefix for 3 is tri. The prefix for 4 is tetra. And the prefix for 5 is going to be penta. That's as far as we're going to go in this class. So if we look at the first problem where it says carbon dioxide, there's no prefix on the first one. And so if there's no prefix on the first one, it's just 1. But it says dioxide, so that's going to mean 2 oxygens. So the formula for carbon dioxide is simply CO2. Now the next one is still carbon and oxygen, but it's going to be in a different ratio of these nonmetals, okay? And it says carbon monoxide. Well, we still have carbon here, but this is like mono. Mono means 1, so it's just 1 carbon with 1 oxygen. So the formula is going to be just CO for carbon monoxide. The third problem that we have here as an example is silicon tetrachloride. Silicon being Si, chloride being Cl, but it's tetrachloride. And tetra is going to tell us that there's going to be 4 chlorines. So SiCl4 for silicon tetrachloride. The last one now, it does have a prefix here. It says di, okay? Remember, when there's no prefix on that first word, it's 1. The second word is always going to have a prefix if it's covalent. But if the first word is not going to have 1 element, okay, it's going to use those prefixes of di, tri, tetra, or penta. So this one's dinitrogen trioxide, so it's going to be N2O3. And that kind of concludes the covalent bonding, and that's when you have two of these nonmetals that are bonding, you have to use prefixes, okay? Now, the next thing that we're gonna do is ionic bonding, and that's typically when you have a metal and a nonmetal. Now, this requires a little bit more thinking and a little bit more time, but these compounds, they don't use any prefixes, okay? So what do we have to do for ionic bonding? Okay, well, if you look at these steps, we're gonna look up the charge for the positive ion, we're gonna look up the charge for the negative ion, and then we're gonna continue to help the loser, okay, until there's a tie between the positive and negative charge. We want our compounds to be neutral. So if you're gonna try to create a ratio of positive ions to negative ions where they cancel each other out. So if I have a positive charge that's 6, then I need a negative charge that's 6 in order for them to cancel out. So the best way to learn this is just by going in and doing some problems, okay? Now I got a couple columns here at the very bottom, okay? This is gonna be my final answer. And this is the work that I'm gonna do to get to that final answer. Now, when you're first starting out with formula writing, I'm really gonna ask you to do this work to show me that you really understand the underlying concept of having these charges cancel each other out, and then to get to the final answer. But as we progress in this class, just writing down the answer will be good enough. But that will probably be like in unit 2, 3, or 4 of this class, okay? So, I'm going to bring out my periodic table that has all the charges, okay? And we're just gonna follow along, based on these directions. So the first problem that we have is gonna be sodium oxide, which really is sodium and oxygen. So I have to have my elements memorized, and I need to know that sodium, okay, is Na. And Na falls in the +1 column. So underneath my work, I'm going to put Na with a +1. Okay, remember, when we don't write the number in front, we assume 1. And then I'm gonna look up oxygen, and oxygen falls into the -2 column. So I'm gonna come over here to my work, and I'm gonna put a -2. Okay, so we found the charge for the positive ion, we found the charge for the negative ion, and now we're gonna help the loser until there's a tie between the positive and negative charge. Well, the positive side has a score of 1, and the negative side has a score of 2. So it's like 1 to 2 right now. So we're gonna help the loser, which is going to be the sodium. And when we do that, the score is now a score of 2 for the positive side, +1. +1 is a total of 2. And we have a score of -2 on the negative side. So we have this tie here between the positive charge and the negative charge. And now we need to do step 4, which is simply count the number of ions and write the formula. So we used 2 sodiums and 1 oxygen. So the formula should be Na2O as an answer. And now we're gonna work the next 4 problems together to make sure that you really have this down, okay? So the next problem is going to be strontium chloride. So I'm gonna look up the charges. Strontium is in the +2 column. And chlorine is in the -1 column. And after we look them up, we're gonna help the loser until there's a tie. This time the positive charge is winning and the negative side is losing, so we help the loser. We got +2 versus -2 now. We got our tie, so we count them up. 1 strontium, 2 chlorines. So strontium chloride is gonna be SrCl2. Lithium nitride is next. Lithium's a +1, nitrogen's a -3. As you can see, the negative is really winning, 3 to 1. So we're gonna help out the loser but the negative side is still winning, 3-2. So you help the loser again. And now we got our tie of 3-3 as far as the charge is concerned. Count everything up, 3 lithiums, 1 nitrogen, and write your formula, Li3N. Next one is aluminum bromide. Aluminum's right here for a +3 charge. Bromide's a -1. And we can see we don't have a tie here. And we're going to help the bromide side 2 more times to get this tie of +3 with the -3. And we count them up, 1 aluminum, 3 bromines. And we get our formula of AlBr3. And then finally we got magnesium phosphide. Magnesium being a +2 and the phosphide being a -3. So we got this +2 versus a -3. So we just help the loser. And now we got a score of 4-3. Help the loser, this time being the phosphorus. And we got this score of 4-6. You might think this is never going to end, but if you keep helping the loser, you'll eventually get to a tie of 6 versus 6. Okay, and to do that, I needed 3 magnesiums with 2 phosphorus. So 3 magnesiums with 2 phosphorus. And that's how you do ionic bonding when you have elements that are a metal and a non-metal. Okay, now it does get more advanced, okay, and we're going to talk about those more advanced things here on the next page. But basically, this is the underlying foundations of formula writing, where if you have 2 nonmetals, there's no charge, okay? And you're gonna have to use these prefixes. And you just read the prefix and write the formula. But if you do have a metal and nonmetal, then you do have charges, and you have to look up those charges, add to the loser until there's a tie, and then count them up, and then to write your formula appropriately, okay? So the next page deals with some more advanced ionic bonding, and really the next series, level 2, 3, and 4, are just kind of like add-ons to basically the stuff that we've learned here on the first page. To conclude level 1 though, we'd like to talk about what we call the D block. Okay, now the D block are these elements right in here. And you might say, well, Mr. Heffel, it's like, you can't look up the charge here, okay? In the D block, it is tricky, okay? And the real story that's going on in the D block is that a lot of these elements in the D block, they can make up more than one type of ion. For example, I know iron can be a +2 ion or a +3 ion. Copper can be a +1 or a +2. So a lot of these elements that are in the D block, which is in the center part of the periodic table, they can make more than one type of ion, and that makes things a little bit tricky, okay? So there's 2 ways that we can deal with trying to figure out what type of ion it's going to be. And we call this the new phase and the old phase, okay? The old phase is going to be discussed in level 2 when we're dealing with polyatomic ions, okay? But in level 1, we are going to discuss the new phase, okay? And what the new phase tells us is that a Roman numeral will be added to represent the positive charge on the D block ion, with 3 exceptions: silver, zinc, and cadmium. Now, silver is going to be a +1, zinc is going to be a +2, and cadmium is going to be a +2. And these are just things that you have to have memorized, okay? If you've done all the things that you're supposed to do before getting into level 1 formula writing, we should have had these ions memorized. And you can see here, silver's a +1, Cadmium's a positive 2, and zinc is a positive 2. Okay, so these are the polyatomic ions that we've memorized before getting into level 1. Okay, all right. So let's take a look. Okay, our first example is iron Roman numeral 3 bromide. Now remember, this Roman numeral is telling us the positive charge. It's not telling us how many there are, it's telling us the charge. So iron with a Roman numeral 3 tells us the charge. And now our D block ion has been undisguised, the disguise is gone, okay? We know that it's a positive 3. Bromide, we need to use our chart, is not in the D block. It falls into our common patterns, and bromide's a -1. And as soon as we know that it's a -1, we can complete the process of formula writing with our work. It's going to take 3 -1s to cancel out 1 positive 3. So we got 1 iron and 3 bromines for the problem, iron 3 bromide. Well, what would happen if that Roman numeral was a 2? Well, if the Roman numeral was a 2, then that tells us that the positive charge is going to be a 2. And if the positive charge is a 2, we will not need as many bromines to get the charge to balance out. Remember, we want this tie to exist between the positive charge and the negative charge in order to do our formula writing, okay? So when we have that tie, we know we'll have a neutral compound. So 1 iron and 2 bromines means the formula is going to be FeBr2. And I think most people know their Roman numerals, but it does come to play every now and then that a student does not know what the Roman numeral IV means. Remember, if it's just I, that's 1. 2 I's is 2. 3 I's is 3. But IV is the number in Roman numerals for the number 4, and then V would be 5, and that's the highest as we go. So it's manganese, so it's Mn, okay, because manganese is Mn. Don't get that confused with magnesium, which is Mg, but manganese Mn with IV tells us the positive charge is 4. Fluoride, we need to look it up on our periodic table. It falls in the -1 column, and that tells us that the charge is going to be -1 for the fluoride. We help the loser until there's a tie. We have to help it out quite a bit. We're going to need 4 -1s to cancel out the positive 4 charge. So this is going to be MnF4. The next 3 problems, you can see, do not have a Roman numeral, okay? And yet they still fall into this D block. And this, like I said before, comes down to our memorization that we need to know silver, cadmium, and zinc. We have to have that memorized. So silver, being a +1, from what we memorized, will get us to the formula, because now that we know that silver is a +1, we just need to look up the oxygen, which is a -2. And if these are not equal to each other, we help the loser until there's a tie. We need 2 silvers for every 1 oxygen, okay? Zinc is a +2. Remember, I got that from the memorization. Zinc's a +2. The chlorine, or the chloride, tells us that it's a -1. So we help the loser until there's a tie, so we get ZnCl2. Cadmium is a +2 from our memorization. And phosphide, we get from the chart, it's a -3. And who's losing between +2 and -3? That would be the cadmium would be losing. But now it's winning, so we help the loser. And now the phosphorus is winning, so we help the loser. And then we get our tie, 3 cadmiums and 2 phosphorus will lead us to a neutral compound, okay? Now here at the very end, I just want to show you that we can do this in reverse, okay? But remember, we have to know where our metals and nonmetals are because that will tell us if we use prefixes or not. So let's take a look at the first problem. It's MgO, okay? So magnesium here is the metal, oxygen is a nonmetal, which means it's ionic, it has those charges, and we will not use prefixes. So we name the metal first, and then we name the nonmetal second, but we're going to take off the ending of oxygen and add IDE. We do that on the last word for both covalent and for ionic. Okay, this next one is carbon and oxygen, so I look up where they're at. Carbon and oxygen are right here. They're both nonmetals, so that means I'm going to use prefixes. Now, if the first symbol only has one, you don't have, that's the only time you don't have to use a prefix. So we just do carbon, but we have one oxygen here, so we're going to use the prefix mono, okay? And then we're going to do oxide. And typically we don't put two O's together, so this is going to be carbon monoxide. Next problem is Al2O3. Aluminum here being a metal, the oxygen being a nonmetal, that's ionic, no prefixes, okay? So we don't have to use a prefix like we did in the last one, okay? So it's just gonna be aluminum oxide. Next one is N2O3, so let's look up where the nitrogen and oxygen are. Ooh, we got two nonmetals, okay? So this is not ionic, it's a covalent, okay? And for covalent, we do use prefixes. The prefix for 2 is di, so this is gonna be dinitrogen. And we got 3 oxygens, and the prefix for 3 is going to be tri, so it's gonna be trioxide. Dinitrogen trioxide, okay? And this concludes kind of like the practice of dealing with ionic and covalent bonding, both with, obviously covalent being with prefixes and covalent with prefixes, ionic without prefixes. I hope this helps you out. There is something on Google Classroom that can guide you with some extra practice, and I'd really like you to practice this really well. Check your answers, okay? And then after you're done checking those answers, and after you've mastered level 1, then you can move on to level 2. And I'll have a link to level 2 in the description below.